Hey everyone, welcome back to Astronomy Daily. I'm Anna.
And I'm Avery. And Anna, today's episode is genuinely one of those ones where I kept saying, wait, what? Out loud, reading the headlines.
Right? We've got auroras on Jupiter's biggest moon that look just like the ones here on Earth. A solar storm early warning system that could give us a whole year's notice before the really dangerous ones hit. A cosmic image that is genuinely going to make you stop scrolling.
And Japan's struggling private rocket company has had yet another very bad day. This is Series 5, Episode 55 of Astronomy Daily. Let's get into it.
So our first story is a beautiful one. Scientists have just published detailed new research showing that Jupiter's largest moon, Ganymede, has auroras. And not just auroras that look strikingly similar to the northern lights here on Earth.
Which already sounds incredible. For listeners who might not know, Ganymede is fascinating in its own right. It's actually bigger than Mercury. It's thought to have a vast liquid saltwater ocean beneath its icy crust. And it's the only moon in our entire solar system known to have its own magnetic field.
And that magnetic field is the key to this story. The research was led by astrophysicists at the University of Liège in Belgium, and they used data from NASA's Juno spacecraft, which made a close flyby of Ganymede back in 2021, coming within about 1,000 kilometers of the surface.
So what did they find? Previous observations had suggested Ganymede had auroras, but they were blurry and low resolution. With Juno's ultraviolet spectrograph, the team could finally see the fine detail, and what they found surprised them.
Right. They expected to see smooth, continuous, oval-shaped glowing bands like a diffuse curtain of light. Instead, Ganymede's auroras are fragmented into a chain of distinct bright patches, each one roughly 50 kilometers across.
And crucially, those same structures, called beads, are something we see in Earth's own auroral displays. They're linked to large-scale rearrangements of the magnetosphere that release enormous amounts of energy. The fact that we're seeing the same thing on Ganymede suggests that the fundamental physical processes creating auroras might be essentially universal.
Which is a beautiful idea when you think about it, that the same magnetic dance that lights up our polar skies on Earth is happening on a moon 500 million kilometers away. The research was published in the journal Astronomy and Astrophysics.
And if you're wondering when we'll get another look, frustratingly, Juno will never fly over Ganymede again. The next close-up opportunity will come in 2031, when ESA's JUICE spacecraft arrives at Jupiter. Until then, these 15 minutes of data from 2021 are all we have.
15 minutes of data that have kept scientists busy for years. That's pretty remarkable, really.
Okay, next up, and this one has real-world stakes. An international team of scientists has developed what they're calling the first system that can actually predict when and where the most dangerous solar storms, superflares, are likely to occur.
And the headline number here is remarkable. They're talking about up to a year's advance warning, which, if you know anything about how solar forecasting currently works, is a complete game changer.
Right, because today we can maybe predict a solar flare a few hours before it happens, if we're lucky. And that's for regular flares. Super flares, the really extreme X10 or stronger events, happen so fast and so unpredictably that they've historically been almost impossible to foresee.
So how does this new approach work? The team, led by Dr. Victor Velasco Herrera from the National Autonomous University of Mexico, analyzed nearly 50 years of X-ray data from solar monitoring satellites. They identified 2 repeating natural cycles in solar activity, one lasting about 1.7 years and another of around 7 years. When those cycles align in certain ways, the risk of superflares increases sharply.
And the system doesn't just give you a time window. It also identifies which specific regions of the sun are at greatest risk. For solar cycle 25, the one we're in right now, the model flags a high-risk window that runs roughly from mid-2025 through to mid-2026, focused on the sun's southern hemisphere.
Meaning we're in it right now.
We are, and the reason this matters so much is what a serious superflare could actually do. We're talking widespread power grid failures, satellite damage, GPS disruption, communications blackouts. For astronauts traveling outside Earth's magnetic protection, like the Artemis II crew heading around the moon, it could pose serious radiation risks.
The team actually validated this approach by demonstrating it correctly anticipated powerful eruptions on the far side of the sun in 2024, events nobody knew about until after the fact. That retroactive confirmation is what gives the scientific community confidence the model is genuinely working. It's been published in the Journal of Geophysical Research.
Lead researcher Dr. Velasco Herrera put it well. We can't tell you the exact moment a storm will erupt, but we can tell you when the conditions are most dangerous, and that lead time is what makes all the difference for utilities, satellite operators, and space agencies planning missions.
Think of it like a hurricane season forecast rather than a specific storm path prediction. You know when to be on guard. That could genuinely save lives and billions of dollars in infrastructure.
Right. Let's take a breath from the "we're all in danger" stories and look at something beautiful. NASA and ESA have released a stunning new combined image of the Cat's Eye Nebula, bringing together observations from two of our most powerful space telescopes, Euclid and Hubble.
The Cat's Eye Nebula is one of those objects that just never gets old. It's a planetary nebula, the glowing remains of a star similar to our sun that expelled its outer layers as it died. Located about 3,000 light-years away in the constellation Draco, it was actually one of the first nebulae ever observed through a spectroscope, way back in 1864.
And Hubble has imaged it before, famously. But this new composite uses Euclid's wide-field infrared capability alongside Hubble's detailed optical and ultraviolet data to produce something genuinely new. You can see the layered billowing shrouds of expelled material in extraordinary detail, along with the intricate inner structures around the central white dwarf.
What I love about this story is what it says about where we are with our telescope infrastructure right now. We have Hubble, Webb, Euclid all operating simultaneously, each with different strengths, and scientists are combining their data to produce views of the universe that no single instrument could achieve alone.
This is also, in a very direct sense, a preview of our own sun's future. In about 5 billion years, our sun will go through the same process, shedding its outer layers, leaving behind a glowing nebula and a dense white dwarf at its core. The Cat's Eye is one possible version of our cosmic obituary.
Cheerful, but genuinely awe-inspiring. We'll have a link to the full image in the show notes. It is absolutely worth seeing full size.
It's just incredible what they keep on finding out there.
Staying in the beautiful corner of the universe for a moment, the James Webb Space Telescope has delivered another jaw-dropping image, this time of a spiral galaxy called NGC 5134. Sitting about 65 million light-years away.
So, not exactly next door, but in infrared, Webb is able to pierce through the dust that normally obscures so much of the galactic structure. And what it reveals is extraordinary. Glowing clouds of gas, stellar nurseries where new stars are actively forming, and the intricate spiral arms traced in enormous detail.
NGC 5134 is what's called a barred spiral galaxy. It has a central bar-shaped structure from which its spiral arms extend. Galaxies like this are really important to study because they let us trace the entire stellar life cycle in one place. From dense clouds of gas where new stars are just beginning to form, right through to older stellar populations in the central regions.
And this image also serves as a kind of reference point for understanding galaxy evolution more broadly. By comparing infrared observations of galaxies like NGC 5134 across cosmic time, astronomers can build a picture of how galaxies grow, change, and eventually, in some cases, stop forming stars altogether.
Webb continues to deliver. Every single week, there's something new. Link to the full image in the show notes, as always.
Okay, we've had two gorgeous images and some landmark science. Time to talk about Japan's very unlucky rocket program.
Poor Kairos. So to set the scene for anyone just joining this story, Space One is a Tokyo-based startup founded in 2018, backed by Canon, IHI Aerospace, Shimizu Corporation, and the Development Bank of Japan. They've been trying to become the first fully private Japanese company to put satellites into orbit using a domestically developed rocket.
Their first Kairos rocket exploded seconds after liftoff in March 2024.
The second one made it off the pad in December 2024, but lost attitude control about 2 minutes in, creating what one commentator described as a very expensive corkscrew in the sky.
And so all eyes were on Kairos number 3, which has been through a genuinely painful week. The launch was originally scheduled for February 25th, scrubbed for weather. Then rescheduled for Sunday, scrubbed for weather again. Then rescheduled for Wednesday, March 4th, which seemed promising.
And then a safety monitoring system activated 30 seconds before liftoff due to unstable signal reception from a positioning satellite, and the launch was aborted. No new date has been set, though the launch window runs until March 25th.
And to be clear, that system activating is actually the system doing exactly what it's supposed to do. This is not a failure in the sense that the previous 2 launches were. It's the safeguard working correctly. But it's still deeply frustrating for everyone involved, including the local community in Kushimoto, who've embraced this as a kind of space tourism attraction.
There's something genuinely compelling about this story because it's about a country's private space industry trying to find its feet in a market now dominated by SpaceX. Japan has excellent government rockets. The H3 has been going well. But the commercial small satellite launch market is where everyone wants to be, and Space One is fighting hard to get there.
We will absolutely be watching. Still a few weeks in the launch window. Fingers crossed for Kairos number 3.
We'll keep you updated.
And finally, a story I find genuinely exciting because it's about solving a problem we've been quietly ignoring for decades. Europe is developing orbital repair robots, autonomous spacecraft that could refuel, fix, and reposition satellites in orbit.
The framing I love here is space tow trucks, which is how the project manager at Thales Alenia Space, Stéphanie Béhar-Lafenêtre, described it. The idea is a robotic satellite with a mechanical arm that can approach a stricken or aging satellite, capture it, service it, and if necessary, push it to a different orbit.
The scale of the problem this addresses is significant. There are now nearly 15,000 operational satellites in orbit. The vast majority were designed to be entirely disposable. Once they malfunction or run out of fuel, they either drift into a graveyard orbit or contribute to the growing debris problem. Repair was never part of the business model.
Thales Alenia Space is planning a demonstration mission for 2028, so still a few years away, that will prove out the capture and servicing technology. One of the clever insights in the engineering is that around 3/4 of all satellites in orbit have robust metal rings that were originally designed for launch. Those rings turn out to be ideal grab points for a robotic arm, even though nobody designed them with that in mind.
There are fascinating legal questions, too. If a French company's robot repairs a South Korean military satellite, who bears liability if something goes wrong during the procedure? These are genuinely unsolved problems in international space law that need to be worked out before this market can scale.
And it's not just Europe. There are parallel programs in the US and China. But this story shows Europe is serious about staking a claim in what could be a very large market. For telecommunications companies running aging geostationary satellites worth hundreds of millions of dollars, the economics of repair versus replacement are compelling.
It's also just a nice idea, isn't it? Space is full of expensive hardware we've abandoned. The idea that we might start going back up there to fix things rather than just launch new ones feels like a more mature relationship with the orbital environment.
And that's our 6 for today. Auroras on Ganymede, solar superflare forecasting, the Cat's Eye Nebula reimagined, a stunning Webb galaxy, Japan's ongoing rocket struggles, and Europe's plans to send robots to fix our orbital infrastructure.
If you want to see any of the images we talked about today, the Cat's Eye, NGC 5134, Ganymede's Auroras, they're all linked in the show notes and the blog post over at astronomydaily.io.
If you're enjoying the show, the best thing you can do is leave us a review on Apple Podcasts or Spotify and share the episode with a friend who loves space. It genuinely makes a difference.
You can also find us at Astro Daily Pod across X, Instagram, TikTok, YouTube, and Facebook. We're back tomorrow with more. Until then, keep looking up.